Tennessee State standard is to apply the Pythagorean theorem to determine unknown side lengths and right triangles in real world and mathematical problems in 2 and 3 dimensions. Today we are focusing on 3-dimensional figures. Your lesson objective: I can use the Pythagorean theorem to find the length of the diagonal in a 3-dimensional figure. So you need to pause the video and write that down. All right, so here we have a 3D figure, and number 1 says find the length of the diagonal of the bottom of the box, which is portrayed by S, and then we're going to use that to find the diagonal of the box, which is R. So let's get this out of the way so we can see. So this bottom of the box is 7 by 3. So 7 squared plus 3 squared equals S squared. 7 squared is 49. 3 squared is 9. And 49 plus 9 is 58. And the great thing about this is at this step we don't have to find the square root, because now we're going to do 2 and S as our sides. So we have 2 squared plus S squared, which is 58, equals R squared. So 4 plus 58 equals R squared. 4 plus 58 is 62, equals R squared. Remember, we take the square root. So R equals, and we're going to use calculator on this, and we'll round it to the nearest hundredth, let's say. So the square root of 62 is equal to 7.87. So now we're going to try a different way of finding this. Let's try taking all of our dimensions and see if it will give us the same measurement, 7.87. So we have 2, we have 3, and we have 7. So let's say 2 squared plus 7 squared plus 3 squared equals R squared. 4 plus 49 plus 9 equals R squared. So R squared equals 49 plus 9 is 58 plus 4 is 62. So this is a shortcut version that you can use. So R, the square root of 62, is 7.87. So this is method 1. This is method 2. You can choose which method you would rather use. You need to have both of these down on your notes. All right, the next one, we have the first diagonal and we have the second diagonal. So we want the second diagonal. So this is the method number 1. We have to find that first diagonal. So we're going to say 5 squared plus 6 squared equals F for first diagonal squared. 25 plus 36 equals F squared. 5 and 6 is 11. 2 and 3 is 5, 6. And so now, to get that second diagonal, we're going to say 3 squared plus 61, because that's F squared, equals S for second diagonal squared. So 3 squared is 9 plus 61 equals S squared. 9 plus 61 is 70. And if we take the square root of both, we get S equals And let's see what the square root of 70 is. 8.37. Now, for those of you who like method 2, let's use method 2. Method number 2 says that we do 3 squared plus 5 squared plus 6 squared equals s squared. 9 plus 25 plus 36 equals s squared. So 36, 41, 61, 70. S squared equals 70. So S equals 8.37. Method 1 and method 2. All right, a wooden plank of the greatest possible length is placed inside a garden shed. Use the diagram to calculate the length of the diagonal of the floor. So we're going to have to do this first. So the floor, we're going to call that F, and we'll call this D for diagonal. So the floor, 1.8 squared plus 2. Oh, nope. Let's go back on that one because I took the wrong. So we have 2.4 and 90. 90 centimeters is the same as 0.9 meters. And we want our measurements in the same unit. So we will do 2.4 squared plus 0.9 squared equals f squared. 2.4 squared is 5.76. 0.9 squared is 0.81. That gives us f squared. So we add these. 1 and 6 is 7. 8 and 7 is 15. Carrier of 1. So f squared equals 6.57, which means we do have to take the square root of this at this time because they want to know the length of that. So the square root of 6.57 is equal to 2.56. So the length of the diagonal of the floor would be 2.56 meters. Now we want the length of the plank of wood. So we're going to go back to 1.8 squared. Let's just do method 2. Plus 2.4 squared plus 0.9 squared equals d squared. So 1.8 squared equals 3.24. 2.4 squared we know equals 5.76. And 0.9 squared equals 0.81. All of this equals d squared. So 3.24 plus 5.76 plus 0.81 equals 9.81. And if we take the square root of 9.81, we get d equals 3.13. So the length to 1 decimal place would be 3.1 meters. All right, here we have a 3D figure, but it's got a 2D triangle that we are dealing with. So here we have a straw, it's like a cylinder, but it comes straight across and then it goes up the side. So that forms our right triangle. All right, so we have a height of 18 and a base or width of 10. So we are looking for We're just going to say C. So we have to do 10 squared plus 18 squared equals C squared. 10 squared is 100. 18 squared is 324. And that added together equals C squared. So 424 equals C squared. We take the square root so that we can find out what C is. And the square root of 424 is 20.59. So then it says, so that is going to be this part. But it wants to know how far above this 24 centimeter pencil will be. So we have to say 24 minus 20.59. We can add a decimal and 2 zeros. So we have to borrow here and here and here. So 10 minus 9 is 1, 9 minus 5 is 4, 3 minus 0 is 3. So the pencil will be 3.41 centimeters above the top of the cylinder. So our Tennessee State Standard was to apply the Pythagorean Theorem to determine unknown side lengths and right triangles in real world and mathematical problems in 2 and 3 dimensions. We focused on 3 dimensions today. And your lesson objective, I can use the Pythagorean Theorem to find the length of the diagonal in a 3-dimensional figure. Happy Friday. Thursday if you're watching this because it's due Friday. And I will see you on Monday. Have a great weekend.